This is Tanner's, Sam's, Harris's, and Cody's water project. Yay!
Wait, so what about this water project?
Crap, isn't it due tomorrow?
I don't know. Water project. Well, don't we have to have like information
And like
Yeah.
a script and
Something
stuff
like
like
that. What's water?
You.
Are you serious?
We're doing a whole project over water.
and you don't know what it is.
Come on. Tanner.
Seriously? It's
Really?
not vital information.
Well,
Well,
we're gonna have to help you out. Really, Tanner? Water, or H2O, is vital to every living life form. It's just about as important as air, as breathing.
Yeah, well, breathing's not that important, see?
Tanner?
Okay, maybe it is a little bit important. So, what is the deal with water?
don't worry, Tanner. We'll help you understand some basic things about water, or H2O.
First of all, the molecular structure of water looks like this. It has two hydrogen atoms covalently bonded to one oxygen atom.
I still don't get it.
Come on, Tanner. It's like Mickey Mouse ears.
Oh, I get it now. No, it's...
Moving on.
Hey, Tanner, let me help you out. I've got a few terms about water that you may need to know.
let's see. Heat of fusion? What is this?
Well, Tanner, heat of fusion isn't a change of temperature, it's a change of state of matter. It takes exactly 6.008 kilojoules over moles of energy to change the state of water from ice to solid, solid to liquid, liquid to gas, vice versa.
What is the universal solvent?
Well, because water is almost able to dissolve any other substance, it is known as the universal solvent.
So, what are solvents and solutes? And what do they have to do with solutions?
Well, Tanner, a solution is usually made up of a solute and a solvent. A solute is usually what ends up getting dissolved by the solvent, which is usually water or another liquid.
You mean like Kool-Aid?
Yes, Tanner. Good job.
What is specific heat?
Well, Tanner, it's specific heat, and it's the amount of energy needed to move a substance up or down 1 degree Celsius. Water just so happens to be 4.184 kilojoules per gram. The formula used to find specific heat is Q equals MC delta T.
The next thing on this list is vapor pressure. What is that?
Okay, Tanner. Vapor pressure is the indication of a liquid's evaporation rate. All liquids have a tendency to evaporate.
Okay, so polar covalent, that has to do with polar bears, right?
Polar covalent means that electrons are shared between elements that have different poles. Water's polar covalent, that's why it's the universal solvent. So what's next on that list, Tanner?
Well, a calorie, low calorie, and a joule. A joule.
Well, Tanner, they all measure heat.
And 1 small calorie is 4.184 joules.
And 1 big C calorie is 1,000 little calories.
You got that, Tanner?
Yes, Cody. Hi there, Mr. Elephant. Hi, Mr. Horse. How are you today? good. Are you sure about that? I think so.
Here, also, I'll do that. Alright.
So, can someone tell me about surface tension?
Okay, Tanner, it's the property of a liquid that allows its surface to resist an external force.
What?
Here, I'll show you. Ha-ha. Okay, here we go. See if these powers still working. Alright, here we go. Now you're gonna watch this, alright, Tanner? Okay, Tanner, this is an experiment to show you surface tension. We got our handy dandy can of black pepper, okay? We're just gonna put it on the surface of this water. Get it all good in there, you know. Okay, now, close that. And we'll take our Dawn dishwashing soap, drop just a little bit on my finger. Just get a little bit of soap on there. Okay. Now, watch what happens whenever I touch the surface. It all goes to the side, and now it starts to fall. This shows that the soap actually broke the surface tension of the water, thus explaining to you surface tension.
Oh, okay. So, what's boiling point and melting point?
Well, Tanner, remember the other day when we found out how hot the pan was?
Yeah. What's that? Crunch bar! Ah!
Well, that pan was hot enough to boil water. The boiling point of water is 100 degrees Celsius, and its melting point is 0 degrees Celsius. Got it?
Yeah.
What Cody just explained is what happens when it changes states of matter.
What's that?
Well, the three states of matter are solid, liquid, and gas.
So what do all those lines mean?
That's what happens when either heat is applied or heat is removed, and it causes a state of matter change by either boiling, freezing, or melting.
Oh, okay.
You guys are going way too slow. Hyperspeed! Electrolytes are substances that conduct electricity when dissolved in water. The non-electrolytes are substances that do not conduct electricity. Water hydration is when water is chemically combined with another substance in a way that is by heating the compound or mixture that the water can be removed. Desiccants are hygroscopic, which means the ability of a substance to attract and hold water molecules from the surrounding environment. Substances that induces or sustains a state of dryness, desiccation, in its local vicinity in a moderately well-sealed container. Efflorescence is the loss of water from hydrate salt to the atmosphere on exposure to air. A suspension is a heterogeneous fluid containing solid particles that are sufficiently large for sedimentation. Fluids are substances microscopically dispersed evenly throughout another substance. The Brownian motion is the random drifting of particles suspended in a fluid. The effect is the scattering of light through particles. Uniqueness of water. About 70% of the globe is covered by water. Life as we know it thrives on this planet because we have water here, and because of water's unique properties. Everything about the physical and chemical properties of water are unusual. Also, many of the geological processes operating near the surface require or are affected by the presence or absence of water. No other planet in our solar system has been shown to have substantial amounts of liquid water on its surface.
For our second experiment, we'll be testing water density. But first, I need to clean off this table. And now... Gonzo Garbanzo. Now, I'm going to have to reset the table. Now I gotta fill up the glass. Now I need my handy-dandy assistant. Oh, there you are, Harris.
What the...
Sorry about that, I needed you for an experiment. Alright, now we need some oil. What? Alright, so to test the density of water, we're going to pour some oil into the glass of water. Because the two have different densities, the oil will float on top of the water. For this, Harris, I don't really need you, so... Okay, here we go. Here we have our water, and here we have a little bit of oil. Just so you know, water has a higher density than oil, therefore the oil will float on top of the water. Again, this shows that water has a higher density than oil.
Our third and final experiment, we'll be showing you how water acts as the universal solvent in many reactions, and also the magic of solutions. We have some Gatorade mix, some water in a pitcher, and a stirring spoon. I will pour some of the Gatorade mix into the water, and then I will stir it to make it actual Gatorade. And notice how the water has taken on the Gatorade mix and dissolved it into making it Gatorade and not just powder and water. Yum!